All right, beautiful people. So this week we're talking about transformations. Yesterday we talked about translations, and today we're talking about reflections. Okay, so we're learning how you can reflect a figure in the coordinate plane. So first thing I want to do is remind us all what a reflection is. Okay, a reflection is a transformation that uses a line like a mirror and reflects a figure across it. Something that I often think about is like if I had this image and then I folded along a line or a line of reflection, what would the image look like on the other side? So it's basically like folding paper. Okay, so remember, a reflection is a rigid transformation, which means that both of the shapes, the image and the pre-image, are going to be congruent. So if you have an angle measure on the pre-image, you know that exact same angle measure on the image. Okay. All right, so let's talk about what a line of reflection is. So notice that we use a line like a mirror. So that line is called the line of reflection. The line of reflection. Okay, it's basically the line that we use to transform or reflect a figure. Okay, so here's my example. I've got the pre-image in green. I've got the line of reflection in red. And then the image in like a off blue, turquoise, kind of. So basically, I just took the paper and I folded it in half. And obviously, this is not to scale because I did not use a ruler. I didn't use a straight edge. I didn't figure that out exactly. So do your best to draw an example in there where you've got a line of reflection and the distance between the image and the pre-image and the line of reflection should be about equivalent, and they should look pretty much the same on either side. If you want to take some time and actually like use a ruler and make sure that you have identical images on either side, I would love that. However, it's not necessary as long as you get the idea that they're both congruent. Okay. All right, so our first example is going to be reflections over the axes. So over the x-axis and over the y-axis. So I'm going to draw a grid. My grid has about 5 marks on either axis, on any of the axes. So I'm going to label them again, just so that I remember. The x-axis is horizontal and the y-axis is vertical. So we're going to start by drawing a picture. Let's just do a line for now, just because it's easier to do that for me. So I'm going to put okay, this is A and this is B. This is line segment A, B. Okay, so the first thing I'm going to do is reflect line segment AB over the x-axis. Okay, so that means that the x-axis becomes my line of reflection. So if I were to like dot the x-axis with this green to show that it's the line of reflection. Okay, so when I reflect over that line, what I need to do is make sure that the distance between the line of reflection and each of my points is congruent. So I'm going to start the distance between the line of reflection and A is 1 unit. Okay, but I don't move it any other distance like to the left or the right. I just move it up and down. So then I'm going to move it down so that it's 1 distance over here. So this would be A prime. Okay, notice the distance is equivalent. It doesn't look equivalent because my scale is off on the bottom from what it is on the top. I apologize, but it's the idea. Okay, also B up here is 1, 2, 3 away from the x-axis or my line of reflection. So I need to put it 3 away on the bottom. So 1, 2, 3. So here's B prime. Okay. So my new line, A prime, B prime, has been reflected over the x-axis. You'll notice that they are, like if I folded the graph at the x-axis, it looks like these 2 lines should line up. Of course, it's not perfect because I don't have a straight edge. I apologize. I really, really do. But I've done kind of the best that I could. Okay, so we reflected AB over the x-axis. So what we're going to do next is compare their coordinates. So the coordinates for A are 3, 1, and the coordinates for B are 0, 3. Okay, and then let's find the coordinates for A prime and B prime.